The temperature inside a room can be modelled by the following equation, where capital T is the temperature in degrees Celsius and lowercase t is the time after 6 am. So our function is t of t is equal to 18 plus 6 sine of pi t on 12. For part A, we're asked to graph the function t of t over the interval 0 to 24 included. Clearly label any axial intercepts, endpoints, maximums and minimums with their coordinates. On the CAS calculator, go into the main menu. Next, what we want to do is type in the equation that we're going to be dealing with in this question. So our equation was t of t is equal to 18 plus 6. And if we bring up the keyboard menu, we can go into trig and sine. And then we have pi times, and we'll replace t with x over 12. And now what we can do is we can highlight that equation and go interactive, define. And the function name, if we use the ABC keyboard, we can turn into capital T of x. And now our function's defined, so it'll just make working with it a little bit simpler. So to graph, we click on the graph screen and we drag T of x down. And now it doesn't look like the graph's appeared, and what we need to do is understand that the graph's probably somewhere that's not shown at the moment. So thinking about our rule, we want to go from t is 0 to 24, so they're our x values for our calculator, so our x min is 0, and our x max is 24. And now the mean temperature is represented by the 18 in the equation, and it goes 6 above that and 6 below. So we're going to go from a minimum temperature of 0 degrees to a maximum temperature of 30 degrees, just to give us a little bit more space on our graph. Hitting OK, and here's our graph. We can now go analysis gsolve and find key features using these commands. So if we find the y-intercept first, that's the t-intercept, and that's at 0.18, and we can hit execute to lock that point on. Then we can go analysis gsolve, and we can use an xcal ycal. So we know that we end when x is 24, so typing 24 in as the x value, we'll do a y calculate, and we find that the y value is equal to 18. We can now go analysis gsolve minimum, and that gives us a minimum at 1812, and then analysis gsolve max will give our maximum at 6,24. One more point that we can find is halfway between our max and min, or halfway between our two endpoints, and that is when x is equal to 12. So we can go gsolve and we can do a y calculate based on x being 12. And after 12 hours, the temperature is 18 degrees. So from the CAS calculator, you can see that our graph looks something like this. And using the analysis gsolve menu, we found that this t-intercept and endpoint was at t is 0 and capital T is 18. We found that this endpoint was at 24 and had a temperature of 18 degrees Celsius. We found that the maximum occurred at 6,24 and that the minimum occurred at 18,12. We also know that this point here is 12,18. For part B, we're asked what are the maximum and minimum temperatures inside the room. So looking at the graph screen to the right where we've marked on the maximum and minimums, we can see that the minimum temperature is equal to 12 degrees Celsius and that the maximum temperature is equal to 24 degrees Celsius. For part C, we're asked to find the time when the room first reaches 21 degrees Celsius. So we can interpret this as needing to solve the equation t of t is equal to 21 over the interval 0 to 24. So to help solve that equation, we can drag down t of x and set that equal to 21. But we don't want to solve across all values of x, we just want to solve over our domain, so we can use this straight up and down line in Math 3 and say that x is greater than or equal to 0, but less than or equal to 24. Highlighting that and going interactive, equation inequality, solve for x will give us x equals 2 and x equals 10. We just want when it's first that temperature, so it's going to be the x equals 2 that we're interested in. Going back to our graph, we can go analysis gsolve and we can do an x calculate based on a y value of 21, and hitting OK gives x equals 2. So that's that same point that we found in the main menu. So using the CAS calculator, that gave us t equals 2 as the first solution. However, we're asked for the time, so we need to remember that t was the time after 6 a.m. So 2 hours after 6 a.m. means that the time is going to be 8 o'clock a.m. So that's the time when it first reaches 21 degrees inside the room. For part D, we're asked what is the temperature at 12 p.m. So that is 6 hours after 6 a.m. So we're asked to evaluate T of 6. To evaluate the temperature when T equals 6, on the calculator we can drag this down and replace X with 6, and hitting execute will give us a temperature of 24 degrees, which is the same maximum point that we found on our graph. So from the calculator we found that that is equal to 24 degrees Celsius, which is the maximum temperature that we found back up in part B. Next, we're told that the room is renovated. As a result, the average temperature is now 20 degrees with a fluctuation of only 3 degrees above and below the mean. For part E, we're asked to give an equation T1 of T to represent the temperature in the renovated room. So our equation T1 of T is going to equal, and the average temperature in the room is 20, so it's going to be 20 plus. And then instead of going 6 degrees above and below our mean, we're only going to go 3 degrees above and below, so it's going to be plus 3 sine. And our period didn't change, so we're still going to have pi t on 12. So this is the equation that we can use to model the temperature inside the renovated room. State a possible sequence of transformations that can be applied to the graph of t of x to produce t1 of x. So on the previous slide, we came up with this second equation, and we want to now map the first equation to the second equation. And to help us do that, I'm going to reintroduce dashes on the variable capital T and lowercase t in the second equation that we're transforming to. And then what we're going to do is arrange these equations to get as much as possible onto the left-hand side or onto the capital T. So for the first equation, t of t, I'm going to start by subtracting 18 and then dividing by 6. So we can write this, and I'm just going to use capital T minus 18 divided by 6 is equal to sine of pi t on 12. And we're mapping that equation. And for t1, I'm just going to have t dashed, and then it's going to be minus 20 divided by 3 when we undo this equation is equal to sine of pi t dash over 12. So what this has done is it's going to allow us to equate the two parts that have capital T together and the two parts that have lowercase t together. So first up, we have pi t on 12 is equal to pi t dashed over 12. And if we have a look at that equation, that just means that t dash, the transform t, is equal to little t. And the second thing that we can equate is going to be capital T minus 18 divided by 6 is equal to capital T dash minus 20 over 3. And now what we want to do in this is solve for the t dash term so we can see what happens to create the transformation. So we're going to start by multiplying both sides of this equation by 3. And when we have multiply by 3 and divide by 6, that's just going to give us 1/2 times t minus 18 is equal to t dash minus 20. Next, we can just expand this bracket, so we're going to have 1/2 times t minus 9 is equal to capital T dash minus 20. And to get t dash by itself, we're going to add 20 to both sides of this equation. And that gives us t dash is equal to 1/2 times t plus 11. So these two statements here and here are going to help to tell us what happens to transform t of t to t1 of t. So the first thing that we can see happening is going to be a dilation by a factor of 1/2 from the lower t axis, the time axis. And that factor of 1/2 from the little t axis is this multiplying factor here by capital T. The second thing that we can see is happening is going to be a translation of 11 units in the positive capital T direction, which is the temperature axis. And this 11 units in the positive direction of the capital T axis is this plus 11 here, which we found before. For part G, we're asked at what times to the nearest minute would the room have been the same temperature before and after the renovations. So this is essentially asking us when is T of T equal to T1 of T over the domain that T is an element of 0 to 24. So on the calculator we can drag down T of X and let that equal T1 of X. Now we don't have that in the calculator, so we can just type it in as being 20 plus 3 and it's sine of pi x over 12. Once again, when we're solving this, it's probably best to restrict the domain. So we use the straight up and down line in Math 3 and tell it to solve between x is 0 and x is 24, both included. Highlighting that and going interactive equation inequality solve for x will give us two values when the room's temperature is the same. Now they're quite difficult numbers to look at, so we're going to turn them into a decimal, and it gives us x is equal to 9.21 and x is equal to 2.787. We can also solve this question graphically. So if we drag down T of x, that's our original room temperature, and dragging down the 20 plus 3 sine of pi x over 12, which is the renovated temperature over the 24-hour period, we can use analysis G-solve intersection to find the points where the room's temperature would be the same. So hopefully you can see that this 2.79 here is the same as the 2.79 here, rounded to two decimal places, and this 9.21 here is the same as the 9.21 that we found in the main menu. So from the calculator we found that T is equal to 2.79 and T is equal to 9.21. So they are the two values of T that give the same temperature before and after the renovations. If we go back and read the question though, it asks for the times, so we need to convert this into a AM or PM time. The CAS calculator can be used to help convert between a decimal and time. So dragging down the 2.79 first, we can go interactive transformation DMS, which is degrees minutes seconds, which is the same as hours minutes seconds. And if we click 2 DMS, it will calculate it for us. Changing this to a decimal, and we can see that it is 2 hours and 47 minutes and 14 seconds. So to the nearest minute, we're just going to have 2 hours and 47 minutes later. Repeating that process for the 9.21, we drag it down, highlight, interactive, transformation, DMS to DMS, changing that to a decimal, and it's 9 hours, and this will be 13 minutes later because 45 seconds is closest to 60 seconds. So we're going to round that minute up to 13. So T equals 2.79 is actually another 2 hours and 47 minutes past 6 a.m. So that gives us a time of 8:47 a.m. And T equals 9.21 is in fact 9 hours and 13 minutes past 6 a.m., which gives us a time of 3:13 p.m. So they are the two times during the day when the rooms would have the same temperature before and after the room has been renovated.